In this video, we're going to be looking at achieved level modeling questions. So first and foremost, you need to understand the parameters in the trig function. The coefficient of the trig function, it affects the amplitude of the function. This value here is your vertical shift, or you can call it the mean value. Now, so with these two, you can figure out what your maximum and minimum are. The maximum is going to be A plus D, and your minimum will be D minus A. So just remember always that your amplitude plus the mean value will give you your maximum, and the mean value take away your amplitude will give you your minimum. Now, if you knew what your maximum and minimum were, to find D, you would have to do max plus minimum and then divided by 2. And that will give you your D. Now, this value here is your frequency, and it's the number of times the wave repeats in a usual period, which is 360, or 2 pi for sine and cos, and pi for tan. This value here is your horizontal shift. Now, you have to remember that it's written as x minus c, so when we actually look at it in the graph, a minus c would shift the graph c to the right, and a plus c would shift the graph c to the left. So just to kind of give you a brief overview of what these terms mean on the graph. So the distance from the middle line to the maximum is your amplitude. This middle line is your mean. That is your minimum. The right at the top is your maximum. And the time taken to finish one full cycle is your period. And to work out your B, it's 2 pi divided by your period. Of course, if you rearrange this, you end up getting period equals 2 pi divided by B. Now we're going to answer a question that you might expect. So in this question, you are told the average number of hours of sunshine per day for a given week of the year in Greytown can be modeled by this equation here. X is the number of weeks since the start of the year, and Y is the average number of hours of sunshine per day. So the question, find the average number of hours of sunshine per day during week 15. So week 15 here is the number of weeks from the start of the year, so X is 15. So all we're doing in this question is replacing X with 15 and substituting into this function. So I'm going to show you how to do that into your calculator. So because you have pi in your function, you know that this is going to be in radian mode. So check that your calculator is in radian mode first, and it is, and then you're just going to enter it in 1.5 times cos bracket pi over 26 bracket x minus 3, and I've got to close off 2 brackets here, and then plus, sorry, and my x is 15, so I need to enter 15 there. Okay, and I end up getting an answer of 6.68. So the average number of hours of sunshine per day during the week 15 was 6.68 hours. Okay, the next question. What is the maximum average number of hours of sunshine per day according to this model? So maximum. Remember, maximum is just the amplitude plus your mean value. So it's 6.5 plus 1.5, which is 8. 8 hours is your answer. Okay, the next question can be done two different ways. It asks you, during which week of the year was the average number of hours of sunshine per day a minimum? You could either just work from drawing a graph or you could solve an equation. So let's first look at it by drawing the graph. So we have a cosine function and we know the maximum is 8.8, and the minimum will be 6.5 take away 1.5, which is 5. So let's just sketch that roughly. So minimum is 5. Sorry, I'll change that a bit. Five is the minimum and max is 8. So the mean value is halfway between those two. Which is 6.5. Now, so let's work out the period. So the b value in this function is pi over 26. Which means period is 2 pi divided by pi over 26. So period is 2 pi times by 26 over pi, which works out to be 52. And there is a horizontal shift of 3 to the right. So just going to mark 3 there, and I'm going to mark 52 plus 3 to the right, which will be 55. So the function is a cosine function, so it starts at the maximum and I can extend it this way a little. So this is what our function looks like. The question asks for us to work out when is it the minimum. Now you can see the minimum is right in the middle of 3 and 55. So there are two ways you can work it out. So one, you know the period is 52, so you can just do 3 plus half the period, which is 26, or you can find the midpoint of 3 and 55. So the easier thing to do is just add half the period from 3. So 3 plus 26, 29 is the answer. So week 29 is when you have the minimum. Another way you could have solved this is by using an equation. You could solve the equation, you know, minimum is going to be 5, so 5 equal to the model, so substitute y for 5 and solve for that, and you can put that into your graphics calculator and work that one out. Okay, next question. Find 2 weeks of the year when the average number of hours of sunshine per day was 6 hours. So you are solving this equation. So I would just put this into the graphics calculator. This is my first function and this is my second function, and I would find the intersection point for them. Okay, so just showing you how to use your graphics calculator again for this. So you go into menu, into your graph. So I'm going to enter the function as one of my functions. So 1.5 cars, bracket, oops, shift pi over 26, another bracket, x minus 3, close bracket, plus 6.5. This is one function, and the other one is going to be 6. Now, when I draw it, I can't see it, and so I have to adjust my view window. So remember, we discussed it, and our period is 52, but there is a shift of 3 to the right. So I'm going to go from 0 to 58. My x minimum is 0, x maximum will be 58. Sorry, 55. And my y minimum is, I'm okay with 0 because the minimum is actually 5 and maximum is 8. So I'm going to go a little higher than 8 to 9. And we've been asked to find 2 weeks of the year. So we're going to use GSolve. So Shift GSolve or Shift F5, and then in the intersection point, the first one's 18.81. So that's week 19. And my second answer is in week 40. And that's all there is at achieved level.